Okay, yesterday we talked about inductive reasoning. We made conjectures based on our inductive reasoning. Uh, Again, that was inductive reasoning, that was personal observation, and we made a conjecture, a statement based on that personal observation. That statement is unproven initially when we make those conjectures. Then you can also make the counter statement, the counter example, which disproves your conjecture. Um, and last night you read the if and only if the conditional statements section. Hopefully you were understood that pretty well. It's a pretty simple section, which is why I had you read it last night. But today we're going to talk about deductive reasoning in our section 2.3. We have some vocab that's important, which is inductive reasoning, the law of syllogism, and the law of detachment. Those are the three things that we're going to focus on in this particular section here. All right, so let's just get started. The deductive reasoning is it forms a logical argument using facts, definitions, properties, and laws of logic. Now, one of the things I was giving the example to most of the classes yesterday is, we as students and teachers and people, we make conjectures all the time based on our personal observations. I even told you that crime scene investigators or detectives or those FBI agents or whoever, they also make conjectures initially. And so that's what they do. Initially, they'll come to a crime scene, they make a conjecture by their personal observation, and they say, hey, this is what I think happened. But then after they make that conjecture, if you watch TV or enough TV to know this, or police that are in law enforcement, they make their conjecture based on their personal observation, and then they go on and they find the facts and the evidence to actually prove their conjecture. Or they end up, in some cases, they have the counterexamples to disprove their conjecture. But in any case, they go from using inductive reasoning to make their conjecture to using deductive reasoning to make their final statement or their final conclusion about the scenario. So deductive reason actually takes laws or logical arguments and facts and puts them into play. So let's look at this kind of example of a mouse deal. Okay, it says if you give a mouse a cookie, then he will want some milk. If you give him milk, then he will want a straw. So if you look here, this statement is essentially the same thing as this statement. So this is two separate statements. If you give a mouse a cookie, then he will want some milk. That's one statement. Statement 2 says if you give him some milk, then he will want a straw. Okay, that's a second statement. Now notice how the end of this statement is essentially the same thing as the beginning of this statement. Okay, this is our progression of logic, is what we're doing. So if we give a mouse some cookies, he's going to be thirsty and he's going to want some milk. The logic then goes on to say, well, if he gets some milk, he may need a straw to drink out of that milk. So what the law of syllogism says is that if you start with this, you can just remove that middle part, and your conclusion can be if you give a mouse a cookie, then he will want a straw. If you give a mouse a cookie, he will want a straw. Because again, I'm just removing this part that they have in common. I'm going from the start to the end and skipping that middle part, okay, and just making my conclusion. Again, going back to that detective scenario, the detective makes a conjecture, finds all the evidence, and then has his statement of fact, okay. Well, when the detective goes and talks to the judge, or the detective goes and talks to his boss, he doesn't go in there and say, okay, here's the long story. This is what happened, because this 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 happened. He doesn't do that. It would take forever. Okay? So instead he goes in there and he says, hey, this is what happened. This is my conclusion. And then the detective's boss or whatever will say, do you have any proof on that? And then he says, yes, I have the proof, which is a whole separate story. Okay? A whole separate report. So in this case here, we went from the beginning. The mouse wants a cookie, or if I give that mouse a cookie, and I go straight to the end, I know he's going to need a straw. Yes, there's facts in between, and this works as long as all the statements are logical. There are facts in between, but I know that giving a mouse a cookie is going to lead to him getting a straw. So I can just go straight to that. If you give a mouse a cookie, then he will want a straw. Another way that you can look at this from an algebraic standpoint is, if you remember, when we solve for variables and we use that substitution law, you can say that if x, okay, equals y, and y equals z, okay, because the law of syllogism states if x then y. If y, then z. The conclusion is if x, then z. Okay, let's make that more algebraic. And again, like I said, if x equals y and y equals z, then you can skip that middle part and you can say, well, you know what? That means x equals z. Okay, so if x equals y, and you might want to write this down and help you out. If x equals y, y equals z, and the y is in common, that means that x must equal z as well. So that's kind of an algebraic way to look at it. Okay, so the next thing that we're going to talk about then is the law of detachment. Now, it's similar to syllogism, except it kind of cuts to the chase a little bit quicker. So let's look at our second example here. If two segments have the same length, then they are congruent. Okay, so that's our statement. If two segments have the same length, then they are congruent. Okay, so that's basically our hypothesis. Now, if I state that AB has the same length as CD, my conclusion now, again, now I'm missing that then statement, the if then statement. My conclusion, it's been detached. That's where that detachment comes from. Then the conclusion now is segment AB is congruent to segment CD. So let's look at it again. The detachment says if two segments, or my hypothesis says if two segments have the same length, then they are congruent. Okay, that's my example. So now I'm saying AB, so any two segments. So now I'm saying AB has the same length as CD. Okay, there's no then now. I don't say if AB has the same length as CD, then AB is congruent to CD. I'm taking that out. That's been detached. That's why it's different than a little bit different than the law of syllogism. Okay, my conclusion now, based on this statement, is segment AB is congruent to segment CD. So the law of detachment says if x then y. Well, if my hypothesis is true, then my conjecture is also true. My hypothesis comes from this example here. AB has the same length as CD. Then my conclusion or my conjecture, AB is congruent to CD, is also true. Can you see the difference there? There's no progression like there was with the mouse. In the mouse example, it went if I give the mouse a cookie, then the mouse will want milk. If I give the mouse milk, then the mouse will want a straw. In this case, it basically says, hey, if two segments have the same length, they are congruent, period. So now I take two segments, A and B, okay, and I say A and B has the same length as C and D. My conclusion, therefore, my conjecture is AB is congruent to CD. I'm skipping all that progression. That's why it's detached. The if-then statement is detached from that. Okay, and that basically wraps up our section on deductive reasoning. And this is just the basics. So I'm keeping the video about 10 minutes long so we can keep the basics in there. Tomorrow when you come into class, one of the things that we'll do is we will discuss, before we get into our classwork, we'll discuss some examples of laws of syllogism and laws of detachment. So I want you at home tonight, just while you're thinking about it, just think about a couple of examples that you can create about a law of syllogism and that you can create about a law of detachment with using the law of detachment. And just maybe jot them down so you have them for class tomorrow. It's not going to be like the inductive reasoning guess who, but we'll still do that, and then we'll probably create one as a class before we get started. So be prepared for that, so that way we can get through that quickly, and then you can get started on your classwork for the weekend. All right. And again, if you have any questions over this, or if you're completely lost or completely confused, please make sure you come to tutoring before school tomorrow morning or after school today. I'll be after school anytime. Okay. All right. I'll see you tomorrow.